Hello, everyone. Here we are again with modern atomic theory. And just a quick review from yesterday. If you remember J.J. Thomson and his plum pudding atom, and then Rutherford and his nuclear atom, who left us with the question, what are all of those electrons doing in the atom? Hopefully you've had some time to think about it and wondered, and maybe you already know. So today we're going to talk about Niels Bohr, who came up with some really amazing ideas. He thought a lot about what those electrons have been doing, and he actually received the Nobel Prize in Physics in 1922 for all of his work. And so at the beginning of the century anyway, he was busy formulating some of these ideas. And his model of the atom retained the nuclear atomic idea. So here you see a presentation of what that might look like here with a carbon atom. And he keeps the nucleus, and he decided that electrons would be traveling in circular orbits. This actually was later disproven. However, this was part of his theory at the time. He had some other ideas about the electrons, that the electrons actually exist in specific energy levels, and that they absorb or emit energy in order to move from one level to another. So we're going to talk about that for a little bit. Just to note that his model worked really well for hydrogen, which is the most simple element, obviously, but when he applied it to other elements, it did not work. So this carbon atom, actually, it didn't, the math didn't work out for him with it. But some of these ideas are important to explore, so let's look at them. Here are two vocabulary words for you. I'm sure you've heard of them before, so they're probably not difficult. Excited state and ground state. And those are important vocabulary words because they describe an atom that has energy, that has absorbed energy, and that one or more of their electrons have moved to a higher energy level. That's the excited state. The ground state is when that atom is in the very lowest energy level possible. So all the electrons are down at the lowest that they can go. That's the ground state. So here I drew a little picture. It's trying to look like one that is in your book, with energy increasing as you go up. Here is an excited copper atom. That atom, then, if it's excited, means that at least one of its electrons has moved to a higher energy level. So it's up higher in energy. Now, what happens if that electron drops down here to a lower energy state? Well, this is what happens. A photon of light is emitted. That is the release of energy. It releases energy in this photon of light. Now, copper happens to release green light. Lithium will release red. Every single atom has its own special color of light that it gives off when its electron drops from a higher energy state to a lower energy state. Now, the obvious question, why do different atoms emit different colors? And that's a really good question. If we look at our example here of the copper, the energy that was given off in that little photon of light by the copper atom, the energy in that photon is exactly equal to the change in energy of the copper atom. So as the electron went from a higher energy level down to a lower energy level, it lost a very specific amount of energy, an amount of energy that is exactly equal to the amount of energy in that little photon of light. So that's important to know because the energy of a photon corresponds to a specific wavelength of light. Okay? And a wavelength of light corresponds to a color in the visible region, the visible spectrum. Now, if you look down here at our little chart, you can see that the wavelength of light, here we have 400 nanometers, 500, 600, 700, corresponds very specifically to a different color. And remember, we just said up here that the energy of a photon corresponds to the wavelength. So down here we have shorter wavelength light. It happens to be high energy photons. So the shorter the wavelength, the higher the energy. If we travel this direction on our spectrum, we have increasingly longer wavelengths, okay, and increasingly lower energy of photons. And you can see where the colors obviously fill in and are associated with the different energy levels and the different wavelengths. So, since only certain colors appear for a given element, for example, lithium red or sodium yellow, here's an example of a few right here, each atom has its own color that it will emit. And we also know certain wavelengths of light are associated with those colors. And photons associated with certain amounts of energy being released for that element. Each element is very specifically giving off a certain amount of energy when its electron is moving from one energy level to the next. So what could we say about Bohr's idea that electrons absorb or emit energy to move to another level? Well, certainly we can agree with that from these examples, but we could also say that as these electrons are moving from one energy level to the next, they are emitting a very specific amount of energy. We will have a chance today or maybe tomorrow, depending on when you're watching this, to be able to do our own little experiment and see some of this evidence for ourselves. So one more look at Bohr's model. Bohr's model of the atom, that electrons travel in circular orbits, exist in specific energy levels, and absorb or emit energy to move to another level. The only thing we really have a problem with here is that they don't travel in circular orbits, and we will look at what they do travel in and what their movement actually looks like. It was quite a puzzle for a long time, and some other scientists came up with some really amazing ideas, and we'll study that in probably a few days. So thank you, and we'll see you in class.